Group 23, Standard Heat of Combustion. It is always good to start from the history, and we would able to appreciate better the study of standard heat of combustion. It is all started when the Greek actually started to interpret them in an informal way with the introduction of inflammable principle and followed by generalization of concept by the phlogiston theory in 17th century. It doesn't stop there, but it begins from there when Sir Francis Bacon actually realized that candle flames had a structure, and at the time there is another person, Robert Fludd, proved it with an experiment. This study is being continued by Otto van Guericke that actually proved that the candle would not burn in the air that been pumped. Sir Robert Hooke then discovered that air when combined with combustible substance will produce flame, and comes to Lavoisier that made a huge contribution, concluding that the fixed air that combined with sulfur was identical to the gas obtained by Joseph Priestley, English chemist, and Wilhelm Scheele, Swedish chemist. Lavoisier concluded that the gas is oxygen. Then Sir Humphrey Davy did multiple experiments, yet there is still lacking in materialistic theory of combustion. Thomson did an experiment to prove the concept of heat as a move. Basically, the definition of standard heat of combustion is the amount of energy of a certain substances that being released when it undergo complete combustion with excess of oxygen under standard condition. In term of its equation. Now comes to the theory part. This graph shows that heat of combustion can be calculated depends on the state of water that formed in the products. It could be in liquid or vapor state. We can use the steam table in this case. We can actually conclude from the value of calculation whereby when the heat of combustion is high, the water and products is in liquid state, and for low heat of combustion shows that the water and products is in the vapor form. The model and slide has been designed using Paint 3D to show that the molecules compound can be burned to form atom element that depicts the heat of combustion, unlike heat of formation that form molecule compounds from atom elements. This slide shows the relation between heat of reaction that can be determined from heat of combustion. The equation has been stated for further application. It is important to know about fuels that produces a large amount of heat as waste and can be used economically by using it for other purposes in industries that can reduce waste and reduce cost to treat it. There is also heating value that related to the combustion of fuel that determine the quality of fuel. The equation has been stated to calculate the heating value that also can be represented as absolute value of Hc. There is two types of heating value that is widely known as higher heating value and lower heating value, and their differences is the state of water that being produced as a result of total energy of combustion. For higher heating value, it produces water in liquid phase, and for lower heating value produces water in vapor phase. The model depicts the gas turbine whereby air will be sucked into the engine at the fan and squeezed into compressor. The air will forced onto combustion chamber and mixed with fuels and ignited. The fuels will produce combustion energy and thus will spin the turbine. The application for higher heating value is steam power cycle, whereby the fuel has undergo combustion in boiler and energy has been produced that will convert liquid into steam. The steam will spin the turbine to produce work and convert to electricity. There is condenser whereby the steam will be condensed into liquid being recycled back. In this slide, we can actually see from the previous example of the steam power cycle and turbine, the difference that we can spot is HHV actually consists of water condensation energy, whereas LHV is not. The equation 1 and 2 that has been stated clearly shows that both condensation and vaporization only involves the change state of matter. A finalized equation 3 has been produced as the result of relation between equation 1 and 2. The equation that has been stated in this slide is used to calculate the heating values of mixture of combustible substances that actually relates the mass or mole fraction of the fuels and heating value for respective components. This slide showed the usage of mathematical software, MATLAB, to solve the standard heat of combustion problem. The usage of such software is the calculation and helps us to get precise value.